All right, thank you all. I hope everyone is well caffeinated now, and we're going to begin the second half so we can get to drinks at the end at some point. So we're going to start with a cloud-focused group here, and we're going to start with David Glazer. Thank you.
Thank you. Oh, and I see you've got the timer set to 21 minutes. Someone clued the organizers in that we are not sticking to our 7 + 7 + 7 box, but we are sticking to our 21-minute box. So don't worry. I realize that we are again a gender-segregated work stream here, and I think that is something that is worth addressing, and I don't have quick, short answers to that like everyone else. I'm going to start with a quick intro and then hand it off to Denis, who's going to start going into the details. Those of you who saw me talk a year ago and who saw us talk 2 years ago, we're going to recognize a couple of these slides, and that's a very good thing. So this is a slide that we showed 2 years ago in Orlando saying, here's what we, after listening to driver projects, see as the mission and purpose of the cloud work stream. And it's the idea of taking advantage of modern compute environments by, as you've heard often today, bringing algorithms to the data. That was a relatively new idea 2 years ago. It's not at all a new idea anymore. The other thing we said 2 years ago is, and here's what we think it looks like around how these different pieces work together to let people who want to analyze data stored in multiple places with compute environments in multiple places using multiple tools, connect the tools they want to the data they have in the compute environments that are available and get the results across multiple things. That was the mandate, the first task that we took on as a cloud work stream. And we broke that down into saying, therefore, we need standards for defining and sharing and executing these portable tools and workflows. That's all what we said in Orlando, and we said a year after that, so this was now a year ago today in Basel, we said, all right, against that mission, how are we doing? We said we have now agreed on and blessed the standards for how one defines portable workflows. We have just had a just approved standard for executing portable workflows with the workflow execution service, and then we still were working on another couple of the standards. So what you're going to hear over the next few minutes is very simply taking those two blue empty boxes and saying we now have an approved standard for sharing portable workflows, and we tomorrow hope to have an approved standard for accessing the data you need to run portable workflows. So that means that we've broken our initial vision from Orlando 2 years ago, said here's the problem we want to solve, here are the pieces of technical standards needed to solve it, and what you're about to hear are updates in order on these three standards, on the tool registry service, the workflow execution service, and the data repository service. So with that, I'm going to hand it to Denis to dig into the first of those three.
Okay, thanks. So for the first bit, we're talking about TERS. So the standard that was just approved is basically our idea for how to move those bits of computation around. In our field, the word tool is a little bit overloaded. So we both mean a tool which is a single container, a Docker-like piece of computation with a bit of descriptor logic mashed on top of it, or a workflow where you could have multiple pieces of these containers stuck together, giving data from one to another, in what we often call a directed acyclic graph. We describe things like the input that goes into these building blocks and the output that comes out of them using one of three languages, currently CWL, WDL, and Nextflow. There's a bit of an example of what the API looks like. It's a relatively simple API where you can get information on a particular workflow or get information on a group of workflows. We've worked a lot both with docstore.org and with biocontainers.pro to implement this workflow. There's some links down there for both the people that are interested in APIs, if you want to dig directly into the specification, or a more human-readable introduction. Our implementations currently implement the version 1.0 of the specification, and we are working towards implementing what just got approved, which is the version 2 of the specification. Keep in mind, this isn't really a big change in the direction of the API. It's just a semantic versioning thing where we made a few breaking changes going between version 1 to version 2 of the API. So this is a nice graphic sort of showing our vision of what we're trying to accomplish. Before, people would put workflows into different environments, and while a researcher could put it in one environment, that same workflow would not really be visible to users of a completely different environment. What we're trying to move towards is a vision where people can put workflows into one registry, and that registry can be viewed by all the different cloud platforms around the world. But it's also possible that those registries may exchange information on workflows with each other in order to sort of knit together all that information into a larger collection of tools that are available. So there's some information there about the implementers of the API. So you've got DocStore, Biocontainers, Agora. Users of the standard include things like CWL tool, the reference runner for CWL, DNA stack, the GA4GH testbed, Terra, the 7 Bridges Cancer Genomics Cloud, and Cromwell. So things that we know that we need to do immediately are, now that we've got the standard approved, we need to implement it. So the various API providers will go ahead and take into account the product review committee suggestions and implement the API. API consumers will be able to upgrade as soon as that occurs to take advantage of the new changes. Future work that we anticipate in that quarter or year timeframe would be things like more endpoints to simplify how to share workflows in bulk, to sync up with other GA4GH standards that are in progress, such as service info. And of course, we need to improve our documentation. We also need to think about things like how do we do authenticated sharing, but that's definitely future work. So with that, I'll hand it off to Brian to talk about WES.
Great. Thank you, Denis. So Denis covered the TERS API. I'm going to talk about the Workflow Execution Service API. So taking a step back, what is the Workflow Execution Service API, or WES, what we call WES? And it's really to bring the algorithms to the data. That's the ultimate vision of WES. WES allows you to send workflows to a given compute environment, but do that in a way that is a workflow environment agnostic, so using a common API. So you can see here in this diagram, this walks you through what that process looks like. On the left-hand side, we have a WDL or CWL workflow coming from a TERS repository. And that may be executed against the new workflow execution endpoint on WES with either a direct programmatic client or on a platform that understands how to make WES requests. So once the user has sent the workflow over to WES, WES responds with a status indicator, a status ID, and ultimately the user can get back, and again, this could be programmatic or this could be through a platform that makes a nice GUI on top of this, information about the workflow. Did it complete properly? What are the output files? Again, what WES is doing here is it's adding this abstraction layer from cloud-specific or HPC or other compute environments, providing a common API that systems can build on top of and researchers can use. For more information, you can find our GitHub page here that includes both the Swagger docs and human-readable information. And the other thing is, about a year ago, this was approved as a 1.0, so very exciting to see that in the Basel meeting. So one of the things that we did in the lead up to the Basel meeting and the approval of WES that I think was really cool and important and something that we want to do for other APIs and with APIs and other groups is we built a test bed. So in addition to defining the schema and working with our drivers and implementers to create WES endpoints, we created this test bed that would actually exercise those endpoints with real-world workflows. So what we did here is we worked with Sage Bionetworks and other community members to create this test bed orchestrator. What that would do is, first of all, look up a collection of workflows using the TERS API. Those workflows came from drivers and other projects. They represented real-world workflows. Those workflows were then sent off to each of our WES implementers using the WES API, and the outcome of that workflow was reported back. Okay, so who participated in this? Well, on the left-hand side, you see the actual workflows, the real-world workflows that were essentially provided by AGHA, HCA, TopMed, and other projects. On the right-hand side, we see the WES endpoints that were implemented for this testing process, including the Broad Institute, HCA, Illumina, Veritas, and we also had Globus Genomics, Seven Bridges, and RENCI as part of the Commons effort. The result, at the end of the day, we had many green check marks, which is great. So we were able to send these workflows out into these remote environments, have them report back that they worked properly. Not every box is green because some workflow environments, some WES endpoints support CWL, others support WDL. But what was really exciting about this is not just this matrix here, but it was the interaction between the cloud workstream, those working on the WES specification, and those implementing it. This effort, this testbed, really drove our development of WES. It really helped us understand the implementation of WES, where the schema, where the specification was ambiguous. For example, going back and forth as we ran real-world workflows, we realized that some are very complicated and involve multiple workflow files. And so this was an area that was underspecified in the spec for WES, and by working with our partners that are implementing WES, we were able to discover that as we sent them these real workflows and greatly improve the specification as a result of the WES testbed activity. So that was very, very exciting to see. So in terms of next steps for WES and our future plans here, we of course want to continue to encourage and support the development of WES. We want to work on a registry, which I'll talk a little bit more about later, as well as how WES and DRS, which is a API that I'll talk about next, interact with each other. In terms of longer-term future work, the common theme here is wanting to see how WES and DRS and TRS interact with each other, adding that to the comprehensive test bed that we develop over time, and also looking at how our APIs, including WES, interact with cloud and discovery and Dury work streams. Okay, the next API I want to talk about is the Data Repository Service. This is also known as DRS. So the idea behind this API is it's actually a very straightforward API. It's designed to look up a data object given an ID and present the caller with options for how to get the bytes of that particular file. So this may include giving the user, the caller, options for what clouds to pull from, getting signed URLs, getting native protocols like Globus transfer information. And so on the right-hand side of this diagram, you can see multiple ways of storing information on cloud or HPC infrastructure. DRS sits in between and allows a sort of generic API for this lookup functionality and this negotiation of how to access the bytes. This could be quite useful for a researcher that might be calling DRS directly to figure out how to retrieve a file from a variety of sources, or other users of DRS may include things like the data browsing portals that want to look at content from multiple repositories and represent them in their portal, or what we've seen very commonly is workflow engines want to be able to understand DRS so they can retrieve files from a variety of places on the behalf of the user. So the GitHub page linked here includes a lot of information, including our human readable and also our specification. And the other thing is, as David was mentioning, we're working on DRS 1.0. It's ready to go. We're hoping tomorrow we have good news there, fingers crossed. Send good wishes our way. In terms of implementations, we actually got a lot of traction in the community, and I'm very happy to see the number of DRS servers that have been implemented and having, again, that great dialogue between the implementers and those that are working on the specification. So as of right now, we have IROD's Consortium, Seven Bridges Cavatica, Seven Bridges CGC, the Teradata repository, all as live DRS servers. In progress, Elixir Cloud and HCA, and Illumina has some plans there as well. In terms of clients, we have the standard Swagger Open API client, which can be generated for a wide variety of languages, as well as a client that was built by the GA4GH developers, as well as Testbed and Terra Workbench implementations. And what I want to show on the lower section here, that's a little looping GIF showing a notebook in the Seven Bridges platform, able to pull data using a DRS client from multiple DRS repositories. So this is a good indication of how a user might interact programmatically with these systems in a Jupyter notebook to pull data from a variety of DRS repositories. Very exciting to see that work. Okay, in terms of next steps and future plans, again, we want to make sure that we have all of the DRS available instances of DRS on a registry on our website. We want to continue to figure out the best way that WES and DRS can work together and enhance the WES API to accommodate DRS. And then we also want to look towards our 2020 goals of working across work streams. So looking at how we leverage the WES testbed that I talked about earlier across multiple cloud workstream APIs and also across other workstreams like Discovery and DRSI. Now that leads me to the next topic, which I think is quite cool and really picks up with what we did with the WES testbed. I'm going to talk a little bit about the testbed activities that we have planned for now and how we're going to evolve that into really driving work between work streams. So the WES testbed that I described previously was really instrumental in helping drive forward that API specification and also the implementations of that API. We learned quite a bit in that process. So the key question here is how do we leverage that momentum that we gained from the WES testbed and evolve our own APIs in the cloud workstream and also work with others and interact with others to test the interactions between our work streams and their APIs. So our plans for the testbed that we first started with WES is to take the WES testbed, which is rather focused on that particular testing activity, and generalize it. So work ongoing right now, and you can find out more details at this bit.ly link. The work that's happening right now is we're taking that testbed foundation and we're essentially making it more generic and extensible. So we're working on an orchestrator that can take test plugins, and we can add additional plugins over time. Right now, initially, of course, we have that WES plugin, but what we're working on now is adding in compliance testing plugins for DRS and TERS and continuing to evolve and work on the code of this generic sort of orchestrator. The other thing that's important about this design is we're trying to make sure that we have a standardized result, JSON file that can be fed to a distinct dashboard service. This allows us to decouple the testbed and run the orchestrator, run the tests in multiple locations, and all report back to a central dashboard, which will be quite useful. What we hope this evolves into, so I'm talking about work that we think is going to be through 2019 and early 2020, but what I'm really hoping this evolves into, and I think I have a good indication that this is the direction we're heading, is to take this sort of generic testbed infrastructure and not only look at doing compliance testing for the cloud workstream APIs, but also using this as a platform for testing APIs across work streams. So yesterday we saw an awesome demo by DNA Stack and Google folks on using the Discovery API in conjunction with WES. And so longer term, what we'd like to do is develop test plugins that would allow us to, for example, what's diagrammed here, do a query on Discovery to find DRS URIs, to find things in DRS that you want to compute on, look at DRSI sort of identity, a passport for a mock user, have that mock user's passport be handed to the test orchestrator, which then would go ahead and execute workflows from TERS on the DRS URIs, the DRS files that came out of that discovery search, and ultimately report that back in a comprehensive test bed. So that's what I'm really, really excited about, seeing us work on collectively in 2020 to really push not only the development of the cloud APIs, but also how our APIs work in concert with Discovery, DRSI, and possibly other work streams as well. So that basically summed up what I want to say in terms of the immediate next steps. Right now, we're really trying to get that foundational generic testbed work finished in 2019 and moving on to compliance testing for our APIs so we can have a nice dashboard on GA4GH.cloud that shows you exactly what WES endpoints are available, what DRS endpoints are available, and TERS. And then in 2020, our work is really focused on how do we work across work streams through a more comprehensive test bed. And with that, I want to hand it back to David to do a wrap-up.
All right, so what you've just heard are the three APIs that execute on the original vision that we had a couple of years ago. Just a couple of slides to wrap up, and bear with the analogy for a second here. But a lot of you, in our working group conversation yesterday in the cloud workstream, we talked about our priorities looking forward, and there's an analogy to Maslow's hierarchy of needs, which you've all seen. And actually, I don't know if you've noticed the internet has submitted a friendly amendment to Maslow's hierarchy of needs and said there was a missing one. But in this same mindset, when we were talking about what are we doing both in the cloud workstream and, as you'll see very importantly, across all of the Global Alliance workstreams, is there's an analogy that we're working towards. And everything we do has to be built on a foundation of ethics and security. And then when we set up the workstreams, when we looked at the first go-round of the grand plan for GA4GH, it broke down nicely into here are a set of problems, individual workstreams, individual APIs that need to be built. And over the last couple of years, as you're seeing in this fire hose, we collectively are starting to check off those individual APIs and starting to say, yeah, this is a good building block. Yeah, this is a good building block. Crypt4GH, awesome. TERS, awesome. Starting to see all these pieces coming together. And now what's starting to get exciting is exactly what Brian ended with, is how do they come together? How do we start to snap these different APIs together and show how they play nicely together and start to solve some big problems, which of course is a necessary step on the way to doing that in the real world. That's why we work with driver projects, to using these APIs together to start to apply to real world problems with little details like, hey, did we get the security tokens correct? Aren't little details anymore. Those are fine to be little details when you're working with test data. They're not fine when you're working with real world projects. And of course, the whole point of all of this is to use these tools put together to improve health through understanding and intervention. And that's the arc that we are on the cloud workstream are part of. So thank you.
Thank you, Cloud Workstream. So we have some time for questions. So the most popular one here, so who would like to take this one? You're all three of you have been working on this together.
Jump into the first one just to start with, and because I think it's a natural segue from the pyramid. The kind of the question is, are we there yet at the top of the pyramid? And I'd say we're not there yet, but to the second half of the question, they are absolutely well suited to the clinical use case. I think the intent and the design of at least this set of technical standards should absolutely work well in the clinical world. I think of the ones I can think of off the top of my head, Genomics England may be the closest to starting to use these standards, WES in particular, in an environment that is very much part of the care delivery environment. I think the only technical differences which are important, are that the auth environment is different, and the restrictions on who can run what where are different in a clinical environment than a research environment. Not more or less important, just different. First half, not yet. Second half, no, they're not more suited to research.
Does anyone want to comment on the inclusion of SnakeMake?
Yeah, I can probably comment on that. So currently, for TERS, we support Nextflow, CW, and WDL. We believe that probably would be, our approach would be generalizable to SnakeMake, but we haven't talked to a particular driver project which has made that request, so we haven't put a lot of thought into that particular approach.
So that is also the same case with NextMake then?
Oh.
Nextflow, sorry. I heard you mention Nextflow. Was that also, so it also was saying with that second one?
No, from my perspective, TERS is not really intended to be opinionated about the workflow language. So I think having a variety of workflow languages there, including Nextflow, would be awesome. And it's something that we need to be nimble about adding, I think.
Yeah, to be clear, I think the Nextflow is in there already. It's just the question was whether SnakeMake would be in there as well. And I believe there's nothing about the approach that limits us in that regard. It just hasn't occurred yet.
Pull request.
Yeah.
I'll add one thought on the way we think about should Nextflow be part of WES is there's a tension between anytime you design a standard, there's a tension between saying, yes, we want to support everyone's wish, and building a standard that is so unopinionated that it's not actually a helpful standard. So there are going to be good workflow languages that technically one could use in this environment that we do not consider part of the recommended standard. And there will be others that we do. And those are trade-offs. And I think over time, market forces of just what people want will evolve. But part of our role as standards definers is to put some pushback on saying yes to every request so that we say yes to the ones that actually drive interoperability. Otherwise, we're not helping with interop.
And we did try hard to make sure that our WES API, for example, had the ability to report back information on what it supports. So as this kind of changes in the community, maybe there's convergence here, the WES endpoints, you should be able to programmatically hit them and ask them, what do you understand? What can I send to you? So that's a way that we can help support.
Yeah. We're now inside this deliberation process, so you're getting a taste of the sausage factory. Actually, the second question there is exactly what we're talking about. Yes, multiple languages are in tension with the goal of interoperability, but at the same time, yes, if we told you all, you're all going to use this workflow language, somewhere between a third and a half of you would rebel. So that's the balance that we're striking. I tend to be the one who likes to say no to these kinds of requests. Brian tends to be the one who likes to say yes. We're good co-chairs. Next question. I might be missing some definition of those URI and Perl acronyms. I just looked them up to see if there was an obvious one I was missing, but if not, they are very different. URIs and Perls are basically ways of saying, here's a string that maps to another string to find things on the web, roughly. In intent, I think they are the same in that they are both levels of indirection that say, given a string that describes something, find the something. But DRS is trying to solve some requirements beyond the simple take one string and look up another one, and in particular recognize that there are multiple ways to get access to a particular object. Often for a single object, there are multiple ways to get access. So I might know, because I've done a search and gotten back a result saying, this is the CRAM file that I want to analyze or I want to visualize. And I get an ID for that CRAM file. But then depending on my environment, the right way for me to fetch that CRAM file might be to download it from an Amazon bucket, might be to download it from a Globus system, might be to download it from Google using HTS-GET and others. And each of those might have slightly different authentication requirements and tokens and handshakes to get the security right. So when I request it, I'm doing the right thing. And add on, some of them might be in different localities, and that might be, there's a whole range of possible physical constraints around which access method I want to get. So DRS is an indirection between a logical ID and a physical fetch in the same way a URI is an indirection to a URL, but it's a richer mapping because of the richer environment that we see around biomedical data.
Great, and I think the multiple workflow one can be checked off as well. I think we got that one answered. So does genomics have a unique workflow requirements that necessitates us creating bespoke languages and frameworks?
So my short answer to that is it shouldn't, but it seems to. And certainly there are a couple of times on these workflow projects when we started and we looked at each other and said, there's nothing, I think, Sean, you asked me this at one point, there's nothing genomic specific about what we're doing. Why don't we just do it the standard way oil and gas does it? Or why don't we just do it the standard way the entertainment industry does it? And every search I've seen says every one of those industries has 8 bad standards for solving the same problem. And therefore, the answer is create a 9th. And that seems to be the way of the world around these kinds of languages and frameworks. I would love it if there were critical mass on some of them. In the meantime, let's get critical mass on wardrobe and leave it at that.
I would say we have racial diversity and shirt diversity. This is my attempt to at least improve the diversity situation.
And we have had this question kind of hanging out at the bottom for a while,
Yeah,
so I think the suboptimal acronym.
If the X were a W, I'd be in favor, because it would be more fun to say wowzer, but.
We have to keep with the theme of three-letter acronyms.
Yeah.
Okay, are there any plans on Spark ML-capable workflow engines?
My quick answer is that's an implementation question, and anyone out there who thinks they have a good Spark ML capable engine, and there's many, and some of you in the room use them, can and should package up workflows that they want to make shareable in a way that they can be run via WES, and provide a WES service that says, hey, I have an optimized way of running this workflow because I know I have a back end that's tuned for running this workflow. It's not a standards thing, because when you want to run a workflow, the fact that it's using ML or Mechanical Turk on the back end doesn't change the spec. Here's some inputs. Here's the workflow, here's some inputs, here's some outputs.
And there is a part of the WES spec as well where we try to have a language for describing hints, essentially. So if you're running something that's very different from, say, WDL or CWL, and you're implementing that in a WES WES API as your backend, you may ultimately need to pass in some hints about the instance types or something like that. So I think it's important that we left that flexibility in the API's standards so people could implement things that we hadn't thought of at the time. I think I'll try and take the next one. What about countries which uploading genomic data is illegal? So one thing that we were just talking about this yesterday. We're called the Cloud Workstream, which definitely sounds very specific to cloud. But the APIs that we're working on really are designed to help with data sharing and designed to provide compute environment accessibility. Those aren't necessarily clouds per se. So we've already seen implementations where groups will put WES in front of HPC environments that are private to their researcher community. The same goes for something like DRS. It doesn't necessitate that you're putting this on a public cloud and anyone can access. There is, from our perspective, the API's perspective, it is completely okay to build storage systems in an HPC environment, let's say, and put a DRS API on top of it. What it helps the researcher do is if they're working in that environment, it means that their code for interacting with that local storage is also the same code that they can use to pull in data from public repositories elsewhere. So I think that's the power of having a common API or a series of common APIs, despite the infrastructure not always being cloud.
Yeah, this kind of, maybe it's uppercase and lowercase, but there's cloud as a concept, and there's cloud as a market segment where there are a handful of large companies that provide multi-tenant cloud services. And Elixir is an example of someone who runs a very cloud-like environment that isn't built on one of the big public cloud services. And these APIs work perfectly well in that environment, and they work in smaller and larger environments.
Wonderful, thank you so much.
Great, thank you.
If I can get the jury team to join us up here, we need Tommi, Stephanie, Craig, Melanie, Jonathan, and David. We are going to begin with Tommi.
Good afternoon. So in the next 14 minutes of synchronized swimming, the data use and research identities workstream will give you an update what is happening. So the jury is formed of two main lines of work. So there's data use and there's researcher identities. Data use is led by Melanie and Jonathan, and the researcher identity is led by Craig and Stephanie. Now I need to operate. I hope. No? Next, please. All right. So the main piece of news is from the jury that the researcher identities workstream is proposing a new standard We call it the GA4GH passport, and basically what the standard is about is that we would be able to encode in a standard machine-readable way categories for intended data use, decisions made by data access committees to grant access, ways to apply access using standard terms, and assure that researchers who are applying for access are who they claim to be. So the aim is really to reduce the time it takes to handle data access requests and support the authorities like DACS. So we're trying to standardize the identity and access metadata communications here. Craig will tell details about this and the claims. So basically we are stacking different visas and compiling them to get into a passport. The other piece of news I'll highlight from the DUO line of work is that we are really working on implementations like data sets that a certain country would be proud of and placing them into data services. This sort of shows how the different standards coming from the DURI and the GA4GH as a whole can support the process of expressing terms of use in standard terms coming from DUO, allowing users to log in to data services with their home university or home organization credentials, and supporting the data access committees to grant access. So we are not doing this in isolation of the technical work, which is very exciting and very challenging, very fun, I think. I would like to have a third point here, a vision from Europe how the federated data access for human data could work. So if you can start the video, please.
When you use sensitive data like human genomes in your research, many questions will arise about sourcing and using it. And how should I write this down in the data management plan to meet both the funder requirements of open data and the legal requirements to protect data? For instance, European Genome Phenome Archive EGA is the most used and known archive for sensitive human data. But moving data to and from it is not always an easily predictable process, because data access is protected by European and local regulations. This is why a solution for federating the EGA service for transnational European use has been created. In practice, this means that the sensitive data stays in the original country and is then annotated and authorised for future use with metadata by the Data Access Committee that enables a safely regulated workflow. For example, in Finland, this enables CSC-IT Centre for Science to offer genome data archiving in a safe and juridically compliant way to its research customers. In this European and Nordic-funded pilot, researchers can store and submit the data for the European science community safely.
So basically, we are still looking for people in DURI, experts, to help, especially with the DAC, or Data Access Committee processes. So if you're interested, contact Melissa. And that was the European vision. I'll now give the floor to Duo, I think, to give us more detail what is happening.
All right, so if you haven't heard about the data use ontology, this is a couple slides of introduction to how one practically uses it. Tommi just showed you what it would look like in EGA. So for the data use ontology, if you're a data repository, you use the ontology, which is a collection of terms describing the data use restriction on data set, and you tag each of your data set with those restrictions. For example, a data set can be restricted for health and biomedical research, general research use, there's disease-specific restriction, and so on and so on. So depending on the data you have in your repository, you tag the data set with the corresponding codes. In a second step, a researcher that comes can use the Duo code to do a discovery type of queries. For example, you can go to the EGA website, you can select a Duo code in that little search box, and it will retrieve the data sets that are available according to that level of restriction. You can also use computational tools, and I think Jordi will mention Beacon supporting Duo in the version 2. And finally, if you're a data access committee or member of a data access committee, Duo helps you triage access requests by helping you match the cause on the request from the researcher that want to access the data to those data set restrictions that you've assigned in the first step. So it's really helping you make your work more easily and faster. A quick slide about current implementers of Duo. So we're really happy that we have a worldwide representation. So this is really a great showcase for GA4GH. We've worked this year with a collaborator in Japan to tag their access policy with Duo terms. Tiffany Boatwood and Australian Genomics are not only implementing but contributing back to Duo, for example, by adding Duo in plain language for patient-side consent forms. Our colleagues in H3 Africa are currently tagging their dataset with Duo for deposition into EGA. We're also part of Seneca, that cross-cohort between Canada and Europe. And obviously, we've worked closely with Jonathan at the Broad, who will tell you about the Duo system in a minute. And really, Duo is what you make of it, so please implement it, but contribute back and join us in Duo. Next to Ima.
Thanks. So just to go off of that also, we had a phenomenal kind of help session yesterday to work with some of the driver projects. So we do expect that this map would just have more countries filled in blue when we have this conversation next time. So excited to move forward with that. And as Melanie talked about in that same diagram that's up in the top right, not only can Duo inform data access committees about how to make data access decisions in a standardized way, but what we've actually done with the Duos implementation at Broad is to take that ontology and to align it with a researcher's data access request in our Duo systems, which can be submitted to a data access committee. And then that data access committee is able to not only see the data use ontology codes, but also to have an algorithm which we put into Duos that is backed by the data use ontology that can inform them based on that ontological tree structure in Duo, how that data access request should be decided, whether access should be granted or not. So we're currently piloting that. We've been piloting at the Broad for over a year now and have started to work with a few different data access committees at NIH, and I've had a lot of conversations with driver projects who are interested in using that as well. And then one other initiative that we've just started in the last few months is actually a cross collaboration, which I know we've talked about as an important goal for us as a group at large, is collaborating with the regulatory and ethics workstream to actually approach IRBs around the world to see if they'd be willing to include consent clauses in their template IRBs which map directly to data use ontology codes. This would mean that as soon as a consent form was approved by an IRB, that we could easily tell what the data use terms that consent form represented were, and then easily adjudicate data access decisions as soon as that consent form was approved, and then even faster, of course, if we're using an automated algorithm. So just a few things we're working on, and I'll hand it over to Craig, I believe.
Great. Thank you. Oh, yeah, sorry. There I am. Hi. Yeah, so I just wanted to talk a little bit about the passport standard. I think it's come up on a couple talks, and Tommi introduced it as well. So this is, I'm hoping, ratified tomorrow? Yeah. Yes, hopefully. So it's all about sharing, really. So it's about the idea of a passport in the GA4GH sense is being able to take an identity as an abstract concept and take a bunch of permissions and basically access qualifications, take them in an abstract sense and be able to apply them into different environments. And this can go across in clouds or organizations, but being able to take that identity with you to where you need to use it for access. So one of the main differences with the diagram you see here, you have your standard passport first page that has photograph and date of birth. There's a lot of personal identifiable information. Inside these GA4GH passports, that's not necessary. So we can use standard auth mechanisms that David Bernick's going to talk about later to be able to make sure we know who the person is that carries this passport. And instead, there'll be a minimum amount of personal information inside a passport. And so once we have this, we have a standard language of claims. It's actually the passport has visas in it, and that those visas can encode various types of access. And once we have the standard language of claims, it can be used across many data hosts and custodians. It's not a goal to actually try to make the whole world use one thing. It's more about some of the federation aspects. Okay, so this didn't come out of thin air. There's a long list, 100+ people in Dury and across different work streams that contributed to this. So I just want to say thank you to everybody who did. Where are we here? So this is what a passport looks like. I think you saw this a little earlier, but it has a very thin access token. Again, that's part of the AAI spec. So there's a good collaboration between the passport spec and some of the work from the security stream that implements the token flows and security around that. This thing can flow around, and as it gets to a node in some federated network that wants to make an access decision, they can look inside this access token, and by using standards, they can go back and pull the passport information. All the passport information is a list of visas, very simple format, very little identity information there, but it can be used, for auditing or to revoke access for bad actors. And then the rest of the information is then used when making a decision. It's a policy that can encode what you're looking for a particular type of resource or access. And then this will vary what kinds of, the specification doesn't say what the policies look like. It really depends on the application. So here, just really quickly, really quickly actually, here's kind of, from the time that, as Jonathan talked about, a DAC can make a decision. This can be encoded, this decision to say that someone should have access to a particular data set could be encoded as a visa. So it could hit some database somewhere, and then as you flow from left to right, it gets pulled out of the database, it gets formatted in the standard format, it gets signed so we can check the authenticity, the integrity of it. It then gets aggregated in this thing called a passport broker, that's where authentication happens. People log in, they grab these things from multiple sources, you end up with a pile of visas, they get bundled together as a passport. And then the AAI spec from the security team, really that's what's noted in red between the passport broker and the application. In this case, it can be a cloud application. That's where that flow is well specified. And then a researcher can use access tools to make this flow happen, pull their visas out, present it to the application that's going to check the policies, and then give access directly to, in this case, a cloud bucket. And then that can get passed over to workflows such as West that we already heard about to be able to do access. Now, there's many ways this could be done, so there's still a lot of work to do between the work streams, but we saw an example of that the other day with the work that DNA Stack put together. Another scenario I want to talk about, so that's with full registered access, DACs and all that. There is a lighter weight process. How do I even know I want to apply for this data set? So here's an example using something that EGA and Elixir has put together, where using a couple different visas, 2 visas of a particular variety, they can be combined. It can go through the same flow, and this application, and you notice that the researcher on the bottom versus the data set is separated by the beacon itself. So the types of queries, the types of data that can flow through there is gated based on the beacon interface. And so in this case, someone who can do this once, get their researcher status set up once, they can go run a bunch of beacon queries across different data sets, and they can discover data sets that have interesting data that are worth even applying for. So I'm going to pass it off to Stephanie.
So just a very quick overview of the main ethics and policy challenges we faced and continue to focus on as we move forward. The biggest was producing an accurate enough picture of a person's access-related qualifications for the purposes of an access decision, and making that reliable enough for data guardians to trust, all in the context of data protection. So the content of the visa types and our accountability and trust models aim to achieve this. The second, and really an ongoing challenge, is that of responsible implementation. So the passport spec is only a standard for communicating access-related information, but with the brilliant collaborations with Elixir and Google, And as much sort of example guidance as we can provide along with the spec, we hope to steer its use towards responsible uses that uphold both the data access and data sharing policies that the passport is supporting, as well as data protection and privacy regulation. There was also the delicate balancing act between respecting local ethical and sometimes policy differences, which add complexity without introducing unnecessary fragmentation. And in the context for especially registered access data models, not excluding certain types of users, non-academic researchers is going to be a big focus for us going forward after our V1 product, as well as non-research users, so clinical care professionals especially, but also access for citizen scientists as envisaged by some of the drivers, potentially access for patients and research participants themselves to their own data, or perhaps to the general results of a study, etc. And in all of this, we've tried to be forward-looking, so our primary goal is to make sure that this works for current data access policies, but as much as possible, we're trying to see what they might look like in 5 to 10 years and hope that the passport will be able to support all of those developments as well.
So I'll talk about the authentication and authorization infrastructure. It's kind of the envelope that makes everything that we just talked about here happen. It's a wrapper mechanism that uses regular OIDC to pass along these passports and so they can be trusted. The main thing it brings over traditional OIDC is this thing called a chain of trust, so that a passport can inherit visas from other brokers along the way, and we can ensure that they came from the right place and have the proper provenance attached to them. And federated authorization, as it would be called, has been tried for many years across many industries, and it hasn't really stuck anywhere. And we think that we've really come up with something that could very well stick and go even beyond the world that we live in here. But this is essentially an enabler of the passport using sort of known, understood technologies. And so it's really about open IDC, and it's, as I said, a well-known thing, and it establishes this sort of federated, not only identity, but a federated authorization platform across this entire world. We've already been implemented in a couple different places, and we have more things coming. We have 2 number ones for some reason, but we're going to have more than 2 number ones. We'll integrate it into as many platforms as we can. We have a lot of people who are eager to try it. We'll be releasing a lot of open source software that has these sort of things implemented, so people can see more than just in these diagrams how it all works.
David has more than made up for the lost time there, so thank you for that, David. I appreciate it. If we can bring up the questions, that would be wonderful. Wow, there's already lots of them. That's fabulous. Okay, so can DRSI standards and GA4GH APIs be used for institutions to hold and make available their research data without deposition into EGA and acceptability into journals? Who wants to take that one? I'm nominating you, Tommi.
Does it work? Yes. So this is maybe a question for the evolution of the European Genome Phenome Archive. So basically, the EGA is evolving towards a federated model. So basically, the technologies that the EGA community is developing would allow the countries to manage their genome data locally. So the compatibility with the standards that we are proposing here, it's built in the driver project EGA. So basically, if the technologies of the EGA in the federated world are used and sustained in the country, so they would be compatible. So I think the answer is yes, but I will leave the EBI to answer this, really. That's what I hope.
The next one seems like a good question for Melanie. Got the...
Sure. So a lot of the DUO terms, so DUO, I didn't go into the history or the very technical details. I'm happy to talk about those. We have a poster out if you really want to know more. Jonathan and I will stand there tonight. So the DUO term were based partly on the consent code paper that was written by Stephanie Dyke and collaborator under the Regulatory and Ethics Workstream. And they had acronyms. So, for example, general research use was GRU. A disease-specific term would be DS, and then XX, where the XX represent the disease. Those were what are called shorthands for the full label of the DUO. The short answer to that question is that the XX part in the shorthand, which is just a little synonym on the label, has not been removed yet. However, it will be. The reason is, instead of saying DSXX, because we're using an ontology, because we're using logical connection between terms, now we will be able to say DS is DUO 00007, and the disease to which that restriction applies is Mondo ID 1234 for cancer, or so on. So we are going to leverage not only DUO, but also ontologies that we are working with, for example, for disease representation.
Great. And the next one is talking about, is there a healthcare group using DUO? Do either of you know of any group?
I do not know of a healthcare group. Sorry, I don't see the question very well. I don't know of a healthcare group using DUO. The closest I know of is the application that Tiffany has done for Australian genomics, but no. Do you know of anybody, Jonathan? No.
Okay, now the next question is probably best asked to Giselle, who might be in the audience. What proportion of EGA datasets have DUO tags?
Oh, so I had a chat with Giselle. Giselle, are you around? So at the moment, new submission into EGA are reaching 80% of tagging with DUO terms. This is for new submission. I don't have the overall number. However, we've worked with the Wellcome Sanger to have part of their datasets tagged with DUO. And we've also worked with the THL Biobank in Finland, the Plenary score, to tag the DUO term. So I guess if I had to guesstimate an overall number, I guess we're probably at 10 or 15% at the moment, but we expect that number to quickly ramp up because new submissions are natively tagged. So at the moment, it's been a lot of, retrospective work and trying to contact the data access committee that own the data sets in there and get them to understand the benefits of DUO and tag the data, but this is ramping up.
Okay, the next question, does DUO support restrictions of data? Is it not a more holistic ontology about the data? Maybe the DUO implementation might be a good example of that, no?
So I would say I think the DUO is primarily about the governing the future use of the data. I think there are a number of other terms which we've talked about implementing. I know there are questions about risk levels of data and sensitivity, but I think a lot of this is conversation still to be had. I don't know that there's more specificity. Melanie, I don't know if you have more thoughts.
No, a general rule we've followed for the development of DUO is really, driver project, use cases. So if you have a specific use case around that, let us know. Again, we'll be at the poster tonight. We're here today and tomorrow. There's an open GitHub. Really contribute. It's not evolving if we don't get contribution. If there's a specific use case, we'd love to talk to you. And I think that would also answer perhaps the last question around opt-out consent. So, if you have a specific case, just talk to us or get Melissa to add you to the mailing list.
Great. The next one was about REMS, and we've had some discussions from Mikhail today about that. So if anyone here wants to talk about it, or if we can just pass the squishy mic over to Mikhail, we can do that too.
Well, basically, the REMS, or Resource Entitlement Management System, is a tool that can be applied to support the DAC processes to make them more electronic. So, I think the DUOs is a pretty similar software development project. So we are talking already, comparing what these tools can enable the data access committees to do in a more streamlined way. And I think the real place where this discussion takes place is the GNECA project, Work Package 2. It's led by Jonathan Dersey from Candig. So I think this tagging REMS as a driver project in addition to DUOs, why not? But I mean, this discussion is certainly taking place already.
Great. And so, Stephanie, do you want to take that registered access question?
Yeah. So we've given a couple of examples for registered access, which are in the discovery context, thinking about for beacon access, how we can provide, more of a beacon response to queries than just the existence of a variant. We're starting with, let's say, safe scenarios, but the idea is not to lock up anything that, shouldn't, doesn't need to have that level of protection as opposed to being completely public. And, as I see it, I think probably, I could almost say we see it there, registered access is to open up access to a lot of data that doesn't need a full controlled access procedure. So I hope that answers the question. But we have given examples we're thinking about with biobanks, for example. Can there be a registered access model to look through a lot more detailed data about samples before, for example, applying for sample access itself? That kind of uses of the registered access data access model.
Great. Now, so does DUO provide access to informed consent documents for each data set or data store?
So DUO is really, it's a collection of terms that you use to tag the data set. So per se, it does not allow you to gain access to any of the original informed consent document or anything. So I guess the short answer would be no.
The second question there, are there plans to make an ontology for data use requests from researchers to make applications more machine readable? That's an easy gimme, so I'll give that to you guys.
I think this is a bit what on the first slide that I was speaking of, we presented where we're actually using DUO itself now to structure data access requests inside the DUO system so that those are then machine readable. So in some way, yes, but actually that ontology is the DUO.
Okay, and I'm going to jump to that last one there. Why do we talk about researcher status and not simply modular attributes, since everything's been about DUO so far? So I'll give that over to...
Probably Stephanie's really
Craig or me? Okay. So researcher status is for special access status, such as registered access bona fide researcher status. There's also a visa type, which is affiliation and role, which provides information about. So again, here, this is for use for types of users that might be different. For example, researchers as opposed to clinical care professionals or a citizen scientist, to be able to segregate access policies in that way. So it's a slightly different thing.
Okay, and the opt-out consent question, who wants to take that one?
So I don't think we have anything for opt-out consent at the moment. I'm not quite sure how that would work. And I guess, again, I think I'd be interested in having a bit more of a discussion. So if you've asked that question, please come and talk to us. I'd love to hear your use case. I should add, again, DUO is a collection of terms with specific restriction and logic behind them. It's not tied to a specific process, so it can be used for a discussion with colleagues who are not doing human data, who are not doing any sort of, consent form or restriction. And they say, hey, it's really nice because I could use a no restriction type of term, or I would want my data set to be not for profit use. So it's not tied to human data or data access committee approvals.
Great, and unfortunately we're out of time because I would love to hear the answer to the next question, but thank you all very much. Okay, the next group we have is on variant representation, phenopackets, and Beacon API. So if I could have Reese, Melissa, and Jordi Remla join me up here.
Oh, I'm not going to wait. All right, we'll get started. First, I'm happy to tell you all that VR was finally approved. For those of you who have been in GA4GH for several years, you've heard us talk about VMC and variation representation. It was approved on September 3rd, and so I'll tell you about that approval and what's in VR. Okay, so VR, variation representation, has several aims. The first is an extensible schema for representing all sorts of variation. That's different classes of variation as well as variation on multiple sequence types. It's a schema, so that makes it a message format. It's intended to be used embedded within other tools. It doesn't provide a tool in itself, so it's not exactly a data repository, but could be used to build one, for example. One of the chief goals of VR is to minimize representational ambiguity that shows up in other formats. So for those of you who are familiar with HVS, you might be aware that there are often multiple ways to represent exactly the same kind of variant. VR's goal is to minimize that. I would say that we can't eliminate all sources of ambiguity, but we can certainly minimize them through both data structures as well as recommendations for how the spec is written and how data are represented. One of the key advantages of VR is to provide a shared identifier. By shared identifier, I mean we don't assign identifiers, we compute them on the data itself. Now that's a really important advantage because it means that if you're holding a variation, an instance of variation, you can compute the identifier on that. And if you can compute the identifier on it and everybody else in the world computes that identifier the same way, then you can ask others if they have seen that particular instance of variation. And if you key various annotations on that identifier, then it makes it easy to collate annotations based on those identifiers, those computed identifiers. And then VR also provides an example implementation, and won't talk much about that today, but there is code available that implements everything that I'll present here. And on the right side of the slide here, you can see sort of schematically what VR is really trying to do. It's trying to make a lingua franca for the exchange of information between systems, both the format that you get back from systems as well as the identifiers you use to obtain data from systems. Okay, so I'll walk through a quick example of VR, an instance of VR object. This is, at the top, you'd see the HVS expression, and we're going to translate that into VR. The first thing you'll notice that I'll fess up to right away is that this is not intended for humans, this is intended for machine use, right? And so part of the reason for walking through this is that the trade-off we are explicitly making is expressivity of the kinds of variants we can represent. That necessarily makes the representation more challenging for humans and hopefully less challenging for computers. It also, as you'll see, allows us some flexibility, some extensibility that's built into the schema that is very difficult to layer onto something like HGVS. So this is a record for a simple sequence variant, the one shown at the top, and it consists of several components. So the first is a declaration of the span of sequence. Here it's just a simple interval. It's a range of two endpoints. This is one of the areas of flexibility in the schema. Although this is a simple interval, we have thought about and even implemented other kinds of intervals, so ranged intervals, for instance, that allow you to provide confidence intervals around location. There are many kinds we could have, including relative intervals or based on basically any other expression of where a variant might be on a sequence. That is embedded within a location, which can also have several forms. In this case, it's a sequence location, but there could be other kinds of locations. So for example, you could imagine basing locations on features, not on a span of sequence, but on a named feature like a gene, a symbolic name for a location. And then we also have states, which are also flexible. Here is a sequence state, but you could imagine having, say, a copy number state. So you could use very much the same framework to represent something like, I know that there are 3 copies of this gene, where the gene is the location and the state is the number of copies. What I just described doesn't exist yet. That's part of the roadmap. And then all of this is wrapped up in what we call an allele. That is one of the objects in VR. There are many other kinds of objects that represent variation, for example, translocations and fusions that are also part of the roadmap. Okay, briefly, I want to point out that we are recommending a different way to provide, to normalize variance. This is one of the sources of ambiguity in, particularly in HEVS, but of intrinsic biological ambiguity in where sequences are located. And through some partnership with folks at NCBI, we've adopted something that that we're calling the fully justified variation that is indicated there in the middle, and the major advantage of that is to represent the full region of ambiguity of location of a variant. Briefly, the computed identifier mechanism that I'm showing here, the only thing I really want to draw out on this slide is that the computed identifier mechanism is really bolting together a bunch of freely available standards that are already available. Didn't create something new here. We're using SHA-512, for example, for digests, base 64 URL for encoding those digests and so forth. I think the collection of those is a little novel, but the components that go into them are not novel, and that makes it fairly easy to implement. There are a number of implementations available. So there's a library that we did as part of a demonstration. The BRCA Exchange and VIC both use that Python library, and the ClinGen allele registry actually re-implemented many of the proposals here, the VR methods. And this is the roadmap for where we're going. Love to have participation from any or all. We talk once a week on Mondays, and happy to share that. Finally, I noticed that I forgot to include the URL. All of the code, spec, and so forth are available in the GitHub GA4GH organization under VR spec, and I'll be here through tomorrow night, so feel free to ask any questions, and a number of other VR folks are here in the audience.
All right, everybody. So it's my pleasure to present PhenoPackets on behalf of the Clinical and Phenotypic Workstream. PhenoPackets was also approved at the same time as the VR on September 3rd, so we've been really excited to be at this meeting and hear about some of the most recent implementations, which we'll talk about. So why PhenoPackets? So we have encodings, computable encodings for things like variants. Even as simple as encoding a FASTA file with ACs and Ts and Gs. But for phenotypes, we have terminologies. We have terminologies for laboratory tests with LOINC. We have cancer staging and histology in the NCI thesaurus, and we have atomic phenotype terms in the human phenotype ontology. And these open computable encodings for phenotypes are just as essential for sharing clinical genomics data as the sequence information. So if we really want to interpret all of that fantastic work that we heard about earlier, how we're going to share and compress and access all of that genomic data, we actually have to have clinical and phenotypic data in order to perform the clinical interpretation of those sequence data. But the problem is we have standard exchange formats for sequence data, but not previously for phenotypic information. So we really need kind of a FASTA for phenotypes. And so at one point we had this idea, if we could just take a proxy of all the phenotypic information that one might collect in an EHR or through e-health applications or in patient registries, and just have a packet of that information in a de-identified manner and be able to transfer it around similar to the way in which we might transfer a FASTA file, then that would actually provide at least some level of clinical interpretation for all these sequence data. So PhenoPackets can help us do better. We want to understand phenotypic features for genome interpretation. So we want to know, does our patient have craniosynostosis, brachydactyly, protopsis, I can never say that word, broad thumbs, and many other phenotypic features, some of which might be encoded in an EHR, some of which might be encoded generally actually outside the EHR as observables by a clinician trying to genetically diagnose a patient. We want to know if these things are not observed so that we can build differential diagnostic tools. We want to know how these information are linked to the genomic information, to samples taken from the patient if we have multiple multiple tumor samples, and those samples were analyzed in multiple ways. How are those phenotypes related to those samples? To the parents and siblings of the patient that's being evaluated, how severe are those phenotypes? Are some more severe than others? When were they first observed? Did they go away? Did they change in their severity over time? So being able to represent these basic features of phenotypic elements of a patient have really not been very transferable in any kind of rigorous way or any computable way previously. So, oops, how do I go back? So who are the users and the use cases for phenopackets? So the idea is that, again, it's really like a FASTA for phenotypes. We want to be able to make it as freely available to the many different contexts that we might use it. So, we talked already a little bit about trying to get phenotypic information out of EHRs in a case-level format in a de-identified way. But patients and families can also generate phenotypic information. Many rare disease patients constantly go on Patients Like Me and Facebook and Google for patients like themselves. Why not provide them a more computable format for sharing that phenotypic information? It's useful for diagnostic screening programs to really try to match patients for clinical trials, for patient registries to be able to track longitudinally how a patient's phenotypic features change over time and then make that registry data available for analytics. Specifically for journals where we have a lot of data being represented in summary tables where we can't distinguish which phenotypes from which patient went with each other. So we just have this many patients had these phenotypes. And so that doesn't really provide the statistical significance that we need to support use of those data that we're publishing in the literature for the building of our diagnostic tools. Finally, being able to collate these from around the web, around these different resources in some computable manner so that we can query around the world for anyone generating phenopackets is creating a registry and then making these available in various kinds of databases, web tools, and algorithms where we really want to support free open sharing of phenotypic information at a case level. So sharing case-level de-identified phenotype data really aims to span clinical diagnostic tools all the way towards basic research systems. And we have a number of current demonstrations that have put phenopackets into use. The biosamples database, we actually had someone yesterday say, I just made 2 phenopackets from biosamples. It was wonderful. Phenopacketeer. So we have SolveRD is using phenopackets now. We just heard yesterday about AMED's new biobank network. So all of Japan's biobanks are now going to be in a network generating phenopackets. Cafe Veriome, UCAN is starting to really explore, and we've had a long-standing collaboration with the NIH Undiagnosed Disease Program, which has generated phenopackets even before it was really a robust standard. And then finally, a long-standing collaboration with the Phenotyps team, who has also really helped us evolve this standard over the last few years. So, phenopackets is useful in many contexts. I think the National Genomic Medicine projects, if you want to share de-identified, freely available case-level phenotype information along with your genomic information that you can share publicly, this might be something to think about. The driver projects, we've had many conversations with Beacon, with ClinGen, with the VIC, BRCA Exchange, and the Matchmaker Exchange. And then also other work streams. So really thinking about the phenopacket as sort of a query response element, a way to sort of build cohorts or filter for patients across the many different resources being generated by the GA4GH. I think that was my last slide. So lots of diverse applications. I have 7 seconds left to describe my future work of our work streams. So obviously we're working really closely with the VR specification. We have a pedigree project in the work stream that's being integrated. We're working on cancer temporality and domain-specific staging, serialization in different formats to make it easier to use. And finally, we heard earlier about collaborations with HL7 and ISO also to have phenopackets implementation within those contexts. And before I go, I just really want to thank the workstream, especially David Hansen, my co-chair, Peter Robinson and Jules Jacobson, and Alejandro, who really led the development of the phenopackets implementation and all of the contributions from the rest of the workstream. So thanks very much.
Bring up Jordy. We have his grand entrance here, right? And he's going to talk about Beacon.
Hello. This was a dramatic silence moment. Okay, so Beacon. The Beacon API, I'm Jordi Rambla from the Center for Genomic Regulation in Barcelona, member of the EGA also, and a member of Elixir in general. Today I'm presenting the Beacon API. You know that Beacon has been one of the first products or ideas or projects that Global Alliance has. So talking about Beacon is kind of not new for many of you, okay? But I will try to introduce some things that people is not aware of. So the idea of the Beacon is that you have a question like, have you seen a mutation like this one? And the answer from the Beacon hopefully is yes. So the Beacon is just answering you something very simple, that it's this Boolean answer that yes, true or no, false, and nothing else. But usually the people using the Beacon has this other question. Can you tell me more about this variant? And Beacon now is able to say, yes, I see that in this and that data set in my Beacon, and also with that counting, meaning that many cases, or occasions, I mean, on that many samples. So you have some idea of how frequent this variation is in these data sets. But you can indeed tell me more, and the answer today for Beacon, this is one example because we have more, is yes, with this handover that I will show you an example later, you can go now to where you can request for this access to this data. Or I can put there also as another bubble, these are the data use conditions for this data set. Or indeed I have this additional information that is specific to my Beacon that no other beacons has, because it's related to, I don't know, some specific type of structural variant or whatever. So the Beacon is providing you many more information than this true or false simple thing. This is an example of the typical query. You can see that the query is still able to go into the query string of a URL, so it's still very, very small. So this query is just asking if in a given chromosome, in a given position, you have this specific variant, and I know, or we expect that the reference position is that other. This is just a kind of a matching thing. And the last parameter is, I want to have the details per data set, or I don't care about which data sets are having this variant, please give me just the summarized result for the whole Beacon. And this is the answer. And you see that the answer is very long. Actually, the only thing that is relevant for that is this thing, let's say, that exists, true, nothing else. The other thing is metadata around the response. And metadata like what you have been actually asking, or what is the interpretation I did of what you actually are asking, the version of the API, and if the datasets are included or not. In this case, as you can see, the answer is null. Okay, so this is the Beacon itself. But as I said, we have something that is called the handover mechanism, and this is very, very relevant. The handover mechanism is just a way for you to declare, to state things that you can do from that answer. And when I say answer, I mean different things. So for the wall Beacon, for example, you can say, for this wall Beacon, you have this access form where you can go, so you provide a URL to the access form, or per this data set that is specific, you have this additional information, maybe it's a link to the paper that has provided these results, or you can go per variant. For example, you have examples where we are providing the link to the DBSNP page or to a clean bar, okay? So this is rich. You can put as many things as you want. This morning in another session, I said, if you want to put here a link to a picture of your pet, it's completely fine. Maybe it's not very useful from a genomic point of view, but it's fine, given that the handover is allowing you to do so. You can put there anything that you consider necessary. We have one more interesting example. For example, in the Progenetics Beacon Plus Beacon implementation, what they do is when you do a query, they compute the results from a table, let's say, okay, from a database. And they give you the result and then a link to a page where you can get the details of that result, of that specific query. And for accessing these results, you need to have authentication and you need to have authorization to access this data. But you have the bridge between a Boolean answer to the specific details about the cases that have made up this answer. And this is the handover. And the handover is something straightforward. We have just the type of the handover, a description, so the website that is the client of this thing could put some text around the handover, the actual URL, and this kind of thing. So it's very straightforward also. So Beacon is simple, but it's very powerful. So actually we have hundreds of Beacons implementation. This simple idea that it's very naive, if you want, had plenty of implementation. It's endorsed by many projects. One of the things I will show later is that, very soon, we have plenty of driver projects and not just driver projects having beacons or showing interest in beacons. It's also interesting that Elixir has put funding on it in order to make this move forward and to provide this service to the Elixir nodes. And we have a well-established network of beacons. So this is what many people is referring to the beacon network. It's lighted up by the DNA stack some years ago, and it's having plenty of beacons there registered. And now Elixir is also lighting one Elixir beacon where all the beacons related to Elixir could enlist, okay? So this is the current status. You see this is very powerful. But are we done? No, we are not done. But because when we started to do surveys about what the users want from the beacon, we see that people needs access to variant information, to case information, and indeed to literature, okay? So we had this mechanism, for example, the handover. That way I explained that you can go to have these case details, but we plan in the next version to provide something else that it's not required to go through a handover, okay? So what we started to do when we see that we are not done is talking with different driver projects, you can see them listed here, and also with other projects that maybe are not so interested yet in the beacon, but show some interest, or with other partners that we have. Some of them, for example, are clinical bioinformatics facilities that are providing diagnosis for rare diseases, especially for non-diagnosed rare diseases. So they are the last line of defense on this kind of diagnostic, okay? So this is what we have been doing, and now we have plans for something that we call Beacon B Next, that not the focus of this talk today is not that, although I've been talking about this thing for the last year almost, so it's kind of weird for me to start talking again for Beacon 1.1, but this is the current situation. It's something that you can use today, and we have now proof of concepts of the next version that we hope that will be presented next year as something that is successful and adopted by many partners and teams, okay? Thank you very much.
All right, that's great. Okay, so we have a very upvoted question already. Going over to Reese. Is it possible to describe multiple alternate bases or the same variant?
Or the same, am I on?
Maybe means of?
Yeah, multiple alts, so only not in the VCF sense where you might have multiple alts within as a single variant. You can, of course, have multiple alleles which represent different changes. I hope that answers the question.
Okay. Melissa, would you like to take the next one on phenopackets?
Sure. So we just announced this morning that we have a new project to implement phenopackets in FHIR, actually. So for those of you who are not as familiar with FHIR, FHIR is an exchange format, exchange mechanism for EHR data. Obviously, there's a lot of components that might be in common with a phenotypic profile used for clinical interpretation software. And so what we're going to be doing in that project is actually So because it's an exchange standard, not an actual model, we have to create the phenopackets model and put that into a FHIR resource as an exchange mechanism. And so that will be a way that you could put a phenopacket into or out of an EHR. But of course, you still run into the challenge of the fact that a lot of times with clinical interpretation and deep phenotyping, a lot of that data is not actually in the EHR. So it's really important that the phenopacket can be non-lossy going in and out of the EHR.
Great. Now, Reese, I know you like talking about checksums of IDs, so.
Wow, that's a weird reputation to have. Okay, so the short answer is yes. In fact, it's the recommended thing to do in VR. So VR permits a legal message, allows you to use any named reference for a sequence. When you serialize an object, one of the sources of ambiguity that we want to eliminate is the annoying difference in human names for a particular sequence. And so you must use a checksum-based identifier for the sequence. That means that GRCH 13 and NC00013.11, I think it is, and CM, whatever that is, all of those will collapse. Variants recorded against those distinct sequences will all collapse to the same computed identifier. And regarding the refget, yes, in fact, the checksum that refget uses was actually based on what we did in VMC many years ago. So yes, those are equivalent. They're exactly the same.
All right. Well, either somehow we had a very, very short question session this time around, or but it looks like we are out of time. And so if we can continue that conversation over drinks, you can talk to them, and we'll bring up our very last group. And so first, thanks to this group. So if you guys are all geeked out, we're going to move to something a little more philosophical, and we can bring up the regulatory and ethics and security-focused groups. We have Bartha, Ray, George, and JP.
Jean-Pierre's first. Yes.
Welcome,
I'm not supposed to sit. Good afternoon. Okay, I'm JP. Let me talk about ZIP, the Data Security Infrastructure Policy. Next slide, PAM. So what is ZIP? So it's a document that defines a set of guidelines, best practices and standards. And this is meant to be used in order to operate data security, let's say to provide appropriate levels of data security for, let's say, potentially all driver projects and beyond. So it's not a completely new document. There was already a document of this kind under a different title that existed before, but there was a need for a substantial update or revamping due to, well, on one side to the evolution of the field of security, but also more specifically to the advent of GDPR. And so I'm going to come back to this in a moment. So it's not the only document in this space. There's also two more general documents, so data privacy and security policy on one hand, and also the framework for responsible sharing of genomic and health-related data. Those two are more general. The ZIP is more specific and is meant to be a help to really move to towards concrete implementation. So it's not intended to describe a physical operational implementation, however, nor is it a normative document. So, voilà, so these are, let's say, the stakeholders, and after some debate, so should should we, let's say, align this document to GDPR in spite of the fact that the scope of GA4GH goes well beyond the boundaries of the European Union, and this debate can, in some cases, be slightly emotional. But yet, nevertheless, a consensus emerged, and we have made, let's say, the decision to adopt the GDPR terminology. So you find, let's say, the usual characters of the data controller, the data processor, and then the positioning of the GA4GH with respect to these stakeholders. So if we go a bit more into details, I hope this is readable. So these are, let's say, are the relationships between the stakeholders, the data contributor, data controller, and the data processor, with the idea that the data contributor delegates, let's say, some of the responsibility to the data controller, but the data controller is, as a consequence, accountable vis-à-vis the data contributor. Right? And the data processor essentially is the one who does the work and the computations, and actually is accountable vis-à-vis the data controller. So that's essentially how the whole machinery works. And so this is let's say the operational assurances. The operational assurances that the stakeholders should guarantee are mentioned as follows. So the physical and environmental security have to be clearly defined. The service assurances, the information security oversight and accountability, and the regulatory and policy compliance. And so, as a consequence, there are a number of recommendations to be found in this document. It's not a very thick document, which is around 12 to 15 pages, so don't hesitate reading it if you haven't done it yet, and indulge in it this evening. So it's, it provides recommendations in terms of identity management, in terms of authorization and access control, and so it's a kind of also a connection with the AI that was presented earlier by David Bernick, the privacy protection, the audit logs, data integrity, and so on. Right. So this is my last slide. So in a nutshell, the ZIP DSIP provides a set of guidelines enabling, let's say, a safe, robust, and trustworthy technology infrastructure. And we assume that we will have, let's say, frequency of revision that is going to be roughly every other year to take into account, let's say, the evolution of the requirements and of the technology. And we are aware of the fact that the document is not complete. Let's say it's not complete. Let's say it's complete, but there are additional things that are going to be brought in terms of cryptographic key management, also the dependency analysis, static code analysis, and also runtime protections. And this is also something that we will have to discuss at some point, which is the refinement of the roadmap in terms of security, and we very much welcome inputs. We had wonderful discussions yesterday at the session devoted to security, and then the speed meetings. But we would very much welcome an even higher commitment of the driver project. It would be wonderful to have, at least from each driver project, one person who is willing to be the interface between the driver project and the DSWS, the data security work stream, to make further progress on this fascinating but yet complicated topic. And you see here the email address where to contact us. And I also to give credit to a member of my group, Francesco Marino, who has been instrumental to take into account all the feedback that we have received on earlier versions of this document. And with the Swiss punctuality, I'm going to finish at exactly the end of my time. Thank you very much.
Good afternoon, everyone. With Dutch punctuality, maybe we'll beat out the Swiss. On behalf of the Regulatory and Ethics Workstream, I'd like to report to you on the progress we've made on behalf of Madeleine Murtag, who's co-chair, and Adrian Thorogood, the GA4GH RUSE manager. You'll remember the framework that was the original mission, idea, philosophy behind GA4GH, the right, the human right, the universal right, and we saw it again in the short video of everyone to share in scientific advancement and its benefits. And later when I'm finished, you'll hear the second part of the right, which was very well done on that little video, in the same article, the right for inventors, authors, and so on to be recognized. So the right to benefit, the right to recognize, which form the unique basis for the approach of GA4GH. We did translate the framework into 13 languages, and along with other reviews that we decided to undertake this year, i.e. update, is it still valid, does it still have meaning, is it still good, do we need something else? We started with the framework, and I'm happy to report that in our consultations, no changes were recommended to the framework, so it has stood the test of time. And that's great because we translated it into 13 languages. You can imagine what that would mean if anybody had wanted substantive changes. So thank you everyone for your participation in that exercise. We did, however, make substantive changes to two other GA4GH policies. First of all, the consent policy. And remember, our consent policy is consent to data sharing. So we don't do the whole corpus of possible elements of valid consent. It's consent to data sharing. And thanks to the leadership of Susan Wallace, we did make several changes. You'll find it a more streamlined, a more modern, a more moving towards electronic consent, moving towards clinical consents in terms of clinical genomics and so on. So it's worthwhile revisiting this and using it when you're building your protocols because it's been updated. Similarly, the data privacy and security policy, and note that it used to be called privacy and security, now it's data privacy and security for more precision, underwent substantive changes, again, under the leadership this time of Edward Dove, and also took into account, like this security infrastructure team, the whole impact of the GDPR, which even if it is Europe, has international impact and does affect and will affect how we continue on our data sharing mission. However, we're not frightened by the GDPR, and so you'll see that the language in this privacy and security policy is for proportionate safeguards. We're dealing with data. We're not dealing with devices and drugs in clinical trials. So it's minimal interventionist, and so it's minimal risk, and hence you'll find that the policy is a well-balanced approach to dealing with the privacy and security issues, not only due to the GDPR, but simply, as we've seen from all the tools being built, the incredible IT technologies that we are building here. So, yes. So I have shortened everything, so that allows us to move to our next steps, which has to do with IP, with intellectual property, with the right of attribution, the right of recognition. And contrary to what's sort of a knee-jerk reaction, you hear IP, you think, that's not GA4GH, we're about data sharing. Why are we talking about IP? That locks things up. Well, you'll hear from two experts, or I think are you tag teaming again? You're presenting, Ray's going to present. We're very fortunate to have two incredibly talented contributors to this series of policies surrounding IP, Ray Krasinski from Philips and George Contreras, who also, by the way, contributed to the original SNP consortium and the sequence map, so they know what they're talking about.
And just as a word of encouragement, I think I'm the last update today, so you've almost made it. There's a reason why this is actually the last topic. So this update, as Bart has kind of hinted, is actually a little different than all the other ones. All the updates you've heard up until now have been about work products of the work streams that are going on here. They're all projects and efforts that are intended to go outside of the Global Alliance. This effort is actually something that's intended for the Global Alliance itself, and it'll actually impact all of the work streams. And George and I, and with a lot of help from Adrian, have consulted with some of the people in the work streams who have contributed to this. And so George and I chair this committee, but actually it's been a sort of a rotating band of people from the different parts of the Global Alliance that have contributed to this work. And so there are really like three purposes for this work. One is to encourage open and collaborative participation in standards development under clear expectations. So we want to make sure people who are contributing and bringing stuff into the Global Alliance understand what's going to happen and what are the rules for their stuff being brought into this organization. To ensure that the GA4GH has clear rights to adapt and distribute the contributions under copyright law. So to make sure that these can be uptaken by the work streams, used by the work streams, and brought together into the work products, and that the GA4GH has, these work products are accessible to the world under clear licenses, and also, as Bartha hinted, with clear attribution for those contributions that came in, and that were the building blocks for everything that comes out of this organization. Once this IP policy is approved, it'll immediately sort of bind the individual contributors as a condition of participation in the standards development. So, and this will be sort of communicated through the work streams. But the real plan is to incorporate this into the member organization agreements as we go forward. And so what we've done up until now is worked on a copyright policy, and we've spent pretty much the last year working on that. There's actually two other parts we still need to get to, which is the patent policy and trademark policy. They're up next. But for various reasons, we decided to start with the copyright policy. We have a draft of this policy available, and later on we'll share some links to where you can get access to that. Just to give you an idea, sort of at a high level, what this is. So the workflow sort of is people bring stuff to the Global Alliance. This happens outside the Global Alliance a lot of the times. Documents, some source code, ontology, components, whatever is brought to the Global Alliance. And this is then, as part of the copyright policy, is licensed to the Global Alliance. So we do not require, the intent is not to require contributors to give up their copyright on their work. It's to give the Global Alliance a non-exclusive license to use that work. This was done for several reasons. The biggest reason of which is that many people here want to actually use that work on their own. They want to publish and maybe use it somewhere else. And we didn't want to require people who are contributing here and doing a lot of good work here to have to come back to the Global Alliance to actually get the rights to the work that they brought into it. So we decided to go this route. It's a little more complicated for the Global Alliance, but should be pretty straightforward for the contributors. So that middle box you see is, once that information, whatever it is brought into the Global Alliance, it's then uptaken, it's worked on in the work streams that you all participate in, and then it's turned into work products, outputs of the Global Alliance. And you can see on the right side of that dotted box, there are sort of two things there. One is documents, guidelines, and on the bottom, the little computer represents software-related things, so source code, open source software. And then that's brought outside of the Global Alliance, and that has what we call an outbound license. For the software part of it, we're using the Apache 2.0 license. This shouldn't be a surprise to most of the work streams that have already produced source code and open source software. Many of the work streams are already using the Apache 2.0 license. We do allow an option to use a different open source license, but we want to strongly encourage people to try and standardize on Apache 2.0. And we expect other licenses to be done on an exceptional basis. And that's the main thing I want to talk about. Any questions?
We'll do the question session now. Perfect. Thank you so much. I think you've got a seat over here. unless you wanted to be sitting with your, okay, good. Well, thank you so much. This is begin our last question section. So some part of the data security infrastructure policy, we're going to begin with JP. Would you like to answer that? I don't even understand what it means, so I'm going to leave it to you.
Yeah. I think I do, yeah. So, yeah, true. So maybe SHA-2 is maybe more kind of an example. So it was a balance that was a bit difficult to strike between, let's say, being generic enough in the things we recommend, and yet provide examples so that people let's say, can see what we exactly mean. Now, I mean, of course, this has to be taken with, these recommendations have to be taken with common sense, in the sense that, as we know, all the crypto primitives age, at some point they have to be replaced by, they get broken, they need to be replaced by new ones, and as a consequence, don't take this too literally. These are just more, let's say, examples that are there. Yeah.
Great, thank you. So now we have a question on the copyright policy. It says, what happens to existing copyright on code? So can you really assert copyright on code retroactively?
Well, no, you can't. So we're assuming people who submit code to the Global Alliance have the copyright to that code themselves. You can't submit third-party code to the Global Alliance. That should be pretty obvious, but just to make that clear. So we can't retroactively put a copyright on other people's code. So the idea is, if you write some software and you bring it to the Global Alliance, you have the copyright on that software. If you work for an organization that owns your copyright, so some companies and some universities require you to surrender your copyright, your rights to software to the university. In that case, you'll have to get clearance from a university or your company to do that. But most universities and companies have a process for doing this, and they'll know exactly what to do.
Great. Now we have a question for JP. Someone is a comedian, decided their name is a lawyer.
A lawyer.
Yeah, okay. Under US law, nobody owns data per se, so would you want to clarify what you mean by a data owner?
It's a lawyer, it's probably an American lawyer. Yeah, so well, that's exactly the kind of issue that we face for this let's say, document, that GA4GH is meant to be global by definition, yet legislation happen to be national or regional, and so it's sometimes a kind of a conundrum to come up with let's say, terminology that is going to make all lawyers around the world completely happy. So, but I would very much welcome a formulation that would be fully compliant with US legislation in terms of, it's a very crucial topic indeed, and yet be in compliance also with GDPR. So please write me, and we'll really try to fix this. But thank you very much for this input. Yeah.
Great. Got more questions for IP. So David Glazer has lots of questions apparently, but one of his is that have we thought about any sort of patent non-assert policy for contributors?
Yeah, patent policy discussion is up next. So George and I are going to start soliciting input from people, and the Global Alliance will going forward. So that's our next topic for discussion. Great. And I think all things are on the table right now.
Good. And you're not off the hook. Why Apache 2 and not BSD?
Actually, a lot of that, for Apache 2, it's more because many of the work streams here were already using Apache 2. I think there might be one work stream that was using BSD, so I don't think it's excluded. I think it was BSD. Look at Adrian.
We did do a survey of current practice, and we found that Apache 2 was so popular it was being attached even to documents that were in software. And we didn't notice in current practice that there were other maybe in one case, other licenses used, so that was part of our justification.
Okay, now, David, can you explain this next question of yours? If
I understood the picture right, it would involve us signing a piece of paper. If I understood the picture right, it would involve us signing a piece of paper to contribute stuff to the GA4GH. If that's right, the sooner we see the paper, the easier it'll be for those of us with legal departments to sign it. If not, even better.
So the answer is that's not right. There wouldn't be a piece of paper to sign, and the way that these types of policies are implemented is by adoption by the governing board of the organization, and then, at least until there's an entity for GA4GH showing up, you would assent to abide by the policies of the organization.
Less comfortable.
Well, this is a practice that's accepted at many very large standards organizations. We do think it works, but all the more reason that this organization probably should be more formalized in the short term.
Yeah, I'm not asking for more formality. I'm just asking for, if it happens, give us timeline. That's all.
Okay, so how does copyright work for third-party code submitted by PR in GitHub?
George, you want to take that?
Third party, right. So third-party code shouldn't really be contributed unless whoever the owner is consents to it. You just can't contribute Microsoft Office to GitHub and say now it's part of the global alliance, right? Whoever owns the copyright needs to do the contributing, whether it's directly or indirectly. Part of the policy asks everyone who makes a contribution to represent, that they have the right to make that contribution, and grant the Global Alliance all of the rights that it needs to modify and work on the whatever the product is. And often, if you just have a piece of third-party code, you don't have those rights unless it's open source. It's compatible with our open source scheme.
So if I could add something, and please do correct me if I'm wrong here, but part of the reason we adopted a slightly different policy for software was the recognition that software is not always contributed in whole cloth and is often based on pre-existing code. And in that case, because we have Apache as outbound, whatever we put out will be compatible with other things that are already under Apache. So like any open source project, there would be a need to know about compatibility coming in, but there could be standards that we release part of it under Apache and other parts are under Apache, and then the user only has to follow one license.
Great. So JP, the next question is for you about aligning DSIP into IS management ISO.
Right. Yeah. So if you refer to the document, so in the references, you will see the standards that we have taken into account. Now, for this specific one, okay, I would really welcome, let's say, an email from, or we can have talk afterwards, in terms of what are really the concerns here. Are we not compliant with ISO 27000 in what we have written? Yeah.
Okay. Now there's one about how does copyright work for third-party code? Oh, we already did this one. So are these IP and licensing policies really going to be helpful?
The short answer is
put a name on
yes.
that one.
Yeah, okay.
Good, okay.
They're also necessary.
The answer is
Yes.
absolutely,
Yes.
right?
There we go.
Every organization needs policies like this. At some point, if these standards and ontologies and software are going to get incorporated into products that are out there in the market, most companies will insist on at least knowing what the rules are. They can't take the risk that they adopt something from GA4GH and then, 3 weeks later somebody shows up and says, oh, well, that was really just for demonstration. You never had a right to put that into a product, right? We're trying to make these policies as lightweight and friendly as possible. And if you take a look, you will see they're compared to most standards organizations, they're pretty short and hopefully pretty accessible, but I don't know. I think we need them.
Perfect, and that seems like the absolute perfect place to wrap this up, so thank you all very much. Now, unless Yuen wants to say something, I think that we are ready to drink. So let's do that.